quadratic functions in all three forms, and investigating area word problems. So if we look at this question here, we're going to read it, highlight, and underline. Same as we do with every word problem we have. A rectangular field is to be enclosed with 600 meters of fencing. What is the maximum area that can be enclosed, and what dimensions will give this area? So rectangular field, okay, so that gives me a little visual. I've got a rectangle. It's enclosed with 600 meters of fencing. What's the maximum area that can be enclosed, and what are the dimensions that'll give this area? So rectangular field's enclosed with 600 meters of fencing. Okay, so that tells me it's rectangular. It's going all around with 600 meters of fencing, so that tells me the perimeter is 600. I want to find the area, and I want to find the dimensions. So I'm looking for area, and I'm looking for the area at the vertex, and I'm looking for the length at the vertex and the width at the vertex. That's what it tells me with the dimensions. So the first thing I want to do is create myself some variables to represent the length, width, and area of the field. And I also needed to include, which I forgot on my last page, underline the word meters because that's telling me my dimensions. L is the length of the field in meters, W is the width of the field in meters, and A is the area of the field in meters squared. Since the fence goes all the way around the yard, that's one thing that's going to help us eliminate some of those variables. We can relate the length and the width using perimeter because 2 times the width plus 2 times the length is the perimeter, or 600. We factor out the 2, divide both sides by 2, width plus length is 300, and we can isolate for width, and we can substitute that into a nice table to keep track of our variables. Now we can draw the field and label the sides using only one variable. One side will be L, the other side will be negative L plus 300. We're looking to maximize the area. So what do we need to do? We need to relate the length and the width with the area formula. Length times width, and of course we substitute in for width, negative L plus 300, and we have 3 ways we could determine the maximum area of this field. One would be by completing a square to determine the vertex, another would be using the zeros to determine the vertex by factoring, or wait, it's already in factor form, or use the zeros to determine the vertex by using the quadratic formula. In my opinion, for this particular example, completing the square is not the easiest, but we're going to do it anyway just for a bit of practice. So we need to make this look like it's in standard form, so we can factor out the negative 1 from the L squared and the 300L. The next step to complete the square is take the linear term, divide its coefficient by 2 and square it. So 300 divided by 2 is 150 squared, and then I have to subtract it off to keep the equation balanced. And now these 3 create a perfect square trinomial, and I distribute the negative to the 150 squared. Now I did completing the square pretty quickly. If you need some more practice on that, rewatch the video on completing the square or come see me. What does this tell me? Here's the important part. It tells me the maximum area is 22,500 meters squared, and it happens when the length is 150. Now, what did the question ask me for again? I've already forgotten. It wants the dimension. I've only found the length. Now I need to find the width. And I can do that by substituting back into the table that I started with, put in 150 for length, and lo and behold, the width is also 150 meters. Okay, so the length and width are 150 meters to maximize the field with an area of 22,500 meters squared. Remember, all good word problems always have sentence answers and let statements to begin them so that we always know what we are looking for and what we've given a variable as a name so we know how to use it. The other approach, which in my opinion, way back here when we talked about our methods, completing the square, that was a lot of work. If I use factored form to find my zeros, if I look at this, this is already factored. So if I set my area equal to 0, that's going to make life a lot easier. I have 2 zeros, L equals 0, and negative L plus 300, and I solve that for L is 300. To find the L coordinate of the vertex, I add them up and divide by 2. And I get the length of the vertex is 150 meters. That makes sense. We already found that. Now, how can I find the width? Width is negative L plus 300. I can go back to the table and substitute it in. And how can I find the area? I can substitute into the original equation. And lo and behold, I still get 22,500 as my answer. For a bit of practice before class tomorrow, exercise 6 on page 12, questions 1, 2, and 3.